So far, we're just really talking about the design rationale for the refinements rather than focusing much about the proof, which we will do later. But I think it's always important to understand what's really the rationale for individual guards and also individual invariants. It's so important. Let's now move on to the new concrete events. And this bullet point here just summarize what we just spoke about, right? Remember ML out and IL out. So these are the two old events that are actually refined for their guards. So the driver will simply just follow through the signal. And the other two, ILN and MLN. So these two events are not really regulated by the traffic lights, which are the new bits we introduced in the refinement. So that's why they are simply unchanged. Just remember, we're only refining two events over here, meaning that the proof obligation related to these two specifically have to be reproved and also evaluated more carefully. We'll get there a little bit later. And what about the new events? We got two new events. One of them is called ML, TL, green. Let's try to understand the naming convention over here. We're talking about ML, mainland, TL, traffic lights, and green. So this is not a variable, it's an event. So whenever this event is enabled and also occur, that simply means the traffic lights that's set on the mainland side has turned to the color green. So that's what it means. And symmetrically, we got another event. Can you guess what the name should be? It should be IL rather than mainland, TL green. So that's something we'll see. Let me switch to the iPad and talk about these two new events and see what their guards and actions should be. Let's now talk about, first of all, let me talk about some very important follow-up to what we just said earlier. We said before, whenever we talk about ML out, it's really from the individual driver's perspective, meaning that they will only follow the traffic lights. So that means the traffic light should have been set to green before the driver can actually see it. Agree? Meaning that we should really let this particular events that will turn the MLTL to be green to really consider all the necessary conditions, the guarding constraint, before it can turn the traffic light to be green. Meaning that what used to be the abstract guard to check the global variables, for example, no opposite traffic, and also A plus B less than D, the number of cars are limited. These are the conditions not to be checked by ML out for the individual driver, but they should be checked when we want to turn the green light of the traffic lights. That's really important. So what used to be a single event in the abstract model M1, now we want to split that into two occurrences for the events. It should always be you turn the light green before the first driver can actually go out of the mainland to the bridge. I'll try to write it down in just a moment, but I want to just make sure I say verbally so you can get some intuition right away. Right, let's now talk about these two events. MLTL green, ILTL green, right? The naming convention is rather straightforward. Let me just write down what I just said as a verbal remarks. So MLTL green. So this event, of course, will be expected to turn the light green before any cars are actually allowed to really exit mainland. This will turn the ML, TL, this traffic light specifically, to green. Before, so the before over here is really important. So we are really expecting some sequence of events, occurrences. I'll draw some trace in just a moment. Before a car can exit the mainland, which will be represented by ML out. Right, let me just show you some example trace right away. If you think about maybe after the system has been initiated, right, there might be some occurrences of events, but at some point, every time before ML out can really occur, you want to make sure the light has been turned green. So that means we got ML, TL, and green. This one must occur first before the ML out can actually occur. And it can be multiple ML out and etc. So we do expect some sequence. This may be a little bit still a little bit not complete, but you'll definitely see some complete trace a little bit later. For now, I just want to draw some like an abstract connection between these two events. So always this one should really occur first before we can do ML out. Okay, that's really the point. Symmetrically, for ILTL green, it'll be very similar comments. Let me just write it down just for completeness quickly. Okay, this will turn ILTL to green before, and again, we are really expecting some sequence of events. Right, this one is here is going to turn the ILTL to be green. A car can exit the island. And this will be represented by the events IL out. Okay, let me try to do one more visualization, and then we can move on to talk about what exactly the guard should be. But for now, let me just say one is MLTL, the other one is ILTL, right? And one is about the IL out, and one is about IL out, the other one is ML out. Okay. Let's think about on the diagram, how can we visualize this? MLTL is going to be turned green first. So that would be MLTL green. And this one should really occur first before we can, let's say for a particular car. And after this, maybe there's one new car from the mainland. They actually want to go onto the bridge over here. So this would be represented by ML out. So this will be number 2. And indeed, when ML out is about to occur, would it be enabled? The answer is yes, because it only depends on over here, as we said before, whether or not MLTL is green. And remember, the first events, MLTL green, already turned this traffic light over here to be green. So that's why ML is enabled and it can occur. And the car might just be traveling around along the bridge. And of course, the next event for the same car will be ILN. So that means the car is actually going to go into the island, ILN. Right? So this might be a good opportunity to see some example trace. So this will be number 3. Let's say the car may spend some nice time in the island over here, and then now it will be the time for the car to really return back to the mainland. What the car should really do is it should really make sure it can see the green lights on the edge between the island and also the bridge over here. But of course, before the driver can really see that, that means the lights must have already been turned into green. Otherwise, it might just be red light. In that case, the driver should really be waiting around here, right? So before the driver can really move, which will be represented by IL out, the light must be turned green first. It's kind of symmetric to what we said about this one here, right? Let's just repeat that very quickly. So what's going to happen is, somehow this light over here should be turned green first. So this will be number 4, which will be ILTL green. ILTL green. And then after this, we know that the car should be allowed to really go exiting from the island. So this will be IL out. This will be number 5 over here. Right? If you look at the guards for IL out, that's something we talked about just earlier. And the concrete guard should be ILTL, should be turned to green already. And that one there indeed happened just earlier. So this might just be the first car to see the light turning green. And the car actually gets onto the bridge, traveling for some time, and then now they will be able to get back to the mainland. So that will be really the complete trace that you should really watch out for. Okay, this will be ML in. You might be wondering about one potential flaw of the design. Let's say this. At the time that we actually, let's say at the time that we try to turn this light to be green, in which case we're going to say ILTL to be green. But how can we be sure that this light over here is turned to red at the same time? Because remember, we turned it to be green at the beginning. And let's say at this point, how can we be sure that one is also red, so that we don't really have two-way traffic on the bridge? It's a very valid concern if you're concerned about that point, but we're going to address that a little bit later. Because if we try to use the model as is, we're going to run into some failed proof obligation. That's something we're going to revisit, and we'll see that we have to change our model slightly to improve it. But for now, we're okay. Right, let me recap very quickly and I'll give you the guards for these two. And then we are done discussing the events. You should really make sure you understand about we really have some implicit ordering between the ML TL green, ML out, and also the IL TL green and also IL out. You really want to get your mind straight about why we're doing this. The question now is, what should be the concrete guard for this? You can think about, in this case, since the ML out, the guard depends on whether or not the ML TL is green. And also for IL out, it depends on whether or not the IL TL is green. So that means when you actually turn this one to be green, or turn this one to be green, you have to make sure it's really safe for you to do so. And for that one, we can refer back to the abstract guard that was backing the abstract version for the ML out and ML in. So what we can put is exactly what these are. Right? Let me just write it down. So the concrete guard over here would be C equals 0. In order for me to turn this light to be green, I want to make sure there's no opposite traffic. And also, once the car see the green light and gets onto the bridge, that car alone plus A plus B should be less than or equal to D. So that's why the constraint should be A plus B strictly less than D. So these are the two guarding constraint in order for us to really turn the lights green over here, right? And these two, not surprisingly, correspond to exactly the abstract guard from the M1, right? Let me make that note right away too. So these two are just the same, equivalent to the abstract guard of ML out in M1. And again, why is this? You might be a little bit confused about this. I think I'm really trying to tell you a story to convince you. In the abstract model M1, we didn't really have the notion about traffic lights. So that's why when we talk about ML out, we kind of magically assume the driver would know about A, B, C, and D. So these global counters. But now that we are now in the refinements and where we got introduced the two traffic lights, the individual driver only have to follow the traffic lights. Whereas for the traffic light to be turned green, we have to put these global counters into play. You can think about maybe somehow these global counters might be updated using some sensors or actuators, which we are not talking about in the current refinement, maybe in the next one. So these are some information that will be used to really decide whether we should programmatically turn the lights green or red. Right? Just keep that in mind. What's left is really about what the concrete guard should be for ILTL green. It will be very similar. Right? When should we turn the lights green over here? It should be no opposite traffic, and also there should be at least one car in the island. Right? So what we should do is this one over here should be no opposite traffic, should be A equals 0, and also B should be strictly larger than 0. Right? That's something we have seen already. And not surprisingly, this part over here really is equivalent to the abstract guard of IL out in the abstract model M1. Right, let me highlight what's really important. The abstract guard for ML out in M1. This will be the abstract guards of IL out and also for M1. Right, the abstract counterparts for ML out and IL out. Even though we're only talking about 4 events, but we have to revisit actually more than that. So that's why I want to be careful when I speak about their guards. All right, and let's now go back to the slide to see if I missed anything. So we got these ideas over here. That's exactly what I just mentioned. You can definitely refer to them, and they just coincide with the abstract guard for ML out, because now we do have the notion about traffic lights. So we should really move those conditions, guarding condition, to the traffic light itself, so that for ML out, at the concrete level in M2, we only try to obey the signal from the driver's perspective. Right? Symmetrically, that's what we got for IL out. Okay, you can see the IL abstract guard simply correspond to the guards for ILTL green, the new events. Alrighty, so now we are done with the 4 events, and now the next part will be we should talk about how we can prove the invariant preservation for M2.